Hello, Algebra 2 students. Today we will be doing 6.4 notes, use inverse functions. Before we talk about inverse functions, we are going to talk about inverse relations. But back in semester 1, a relation was just an ordered pair. So an inverse relation is interchanging the x and y values of a relation and so basically what it does is this switches the domain and the range. Domain is x, range is y, but if you switch them, then y becomes the domain and x becomes the range. Let's take a look at an example. So in this table, you have your top row, which is your x values, 0, 1, 2, 3, and 4. And your bottom row, your y values, the range is 6, 4, 2, 0, and -2. We are just going to switch them so that we get an inverse relation. So the bottom row becomes the top row. And the top row becomes the bottom row. Let's graph each one. So we are going to graph the original relation, and I will graph that in, say, green. So we're going to plot these first in green. So notice we have 0, 6. Then we have 1, 4, 2, 2, 3, 0, and 4, -2. We are not going to connect them as this is not a function. It is a relation, so some ordered pairs. We don't connect them when it's just a relation. Now for the inverse relation, so you just kind of see what it looks like. We have 6, 0, 4, 1, 1, 2, 2, 2. These two are identical. 0, 3, and -2, 4. And hopefully you see something there, but these relations are reflections of each other, and they are actually reflections of each other over a specific line. So if we look at the table below, how did we find an inverse? Step 1, we switched x and y. Step 2, you would solve for y. We didn't need to because we didn't have any kind of equation. So inverse relations are reflections. So they're mirror images of each other over the line y equals x. And I will sketch that line for you guys here in a second. So remember, y equals x has a slope of 1 over 1 because that's the number in front of x. And the y-intercept is 0. So start at 0, 0. And then rise 1, run 1 to the right. And keep repeating it. You don't need to make all the dots, but if you're like me and you're very particular about your graph, you probably will end up making it. So I'm going to sketch it in, and I am going to connect these just because then you can actually see the reflection. So notice those are a reflection over that line y equals x. Okay, now for our examples 1 and 2, we are actually going to find the inverse relations without having to make a table of values, which is so much nicer. So we are going to follow these 2 steps right here. So we are going to 1, and I will label my steps for you because that makes it a lot easier. So step number 1, switch x and y. So, and I'm going to even write it for this first problem. So we have x equals 3y minus 5. So I've switched x and y. Step 2, we are going to solve for y. So we have x equals 3y minus 5. We want y by itself, so we're going to add 5 to both sides. We have x plus 5 equals 3y. And then finally divide both sides by 3. And so when we divide both sides by 3, we have two numbers here. So we can just put one bar over 3, or we can put two separate bars and put each of the numbers over 3. Either way it works. So your answer is, when it's asking you find the inverse relation, your inverse relation is y equals, 3's cancel, x plus 5 over 3. That's a perfectly amazing answer. Or you can write it as y equals x over 3 plus 5 over 3. You can always write as long as you only have one number in the denominator, you can write separate fractions. So you can write it like that, and that would be fine. Right, let's do example number 2. And this time I won't say what I'm doing. I'll just number the steps. So step number 1, switch x and y. Remember, this is originally y to begin with, because f of x just means y. So I'm going to switch that. That becomes x equals 3y squared. And step number 2, we are going to solve for y. So I will just rewrite this. You know what? For this particular one, I'm going to go ahead and put y on the left side because I prefer it. Okay, so I'm going to write 3y squared equals x. Divide both sides by 3. Y squared equals x over 3. And lastly, you want to take the square root of both sides. So take the square root. The square root of y squared is just y. And the right side is plus or minus. Whenever we take the square root of something, we have to put the plus or minus in front, or right after the equal sign. And so we won't worry about rationalizing the denominator because we're just writing an equation. We're not simplifying it. So it's okay to have a radical in the denominator. And that is perfectly acceptable for this particular problem. So just two simple steps to remember: switch x and y first, and then solve for y. Now, those are inverse relations. What about inverse functions? Okay, so this is where 6.3 will come into play. The functions f and g are inverses of each other, provided their compositions are equal to x. So if f of g of x is equal to x, and g of f of x is equal to x, then they are inverses. So that must be true. And you must show both. And we will do 2 examples. So hopefully this won't be that difficult. But if you remember, this is the input of g, which then you would get an output for g. That output for g would then become the input for f. And so that's what we're going to do. How do you denote an inverse? So the function g is denoted, this is read as f inverse. So it's not f to the negative first power, it's just read as f inverse. Now, what if your original function was f? Then g would be its inverse. You don't have to call it f negative. Well, I'm not going to say to the negative first power, but you don't have to read it like that. You could just call it g. And that's what I will probably do for the examples. But that's how you would read something like that. An italicized letter like f to that negative first power is actually read f inverse, or the inverse of f. All right. So now, knowing that we know what must be true, let's verify that two functions are inverses. And if this bothers you right here, which it does a lot of people, it's like, that is just too much, like too many f's, then just think of that as this is the same thing, f of g of x. Because remember, the inverse of f, you just can't have f's twice. So the inverse of f is g, and the inverse of g would be f. So if this were g, then this is f of x. But you have to show that both of them are equal to x. And so, and let's always do the f of g of x first. So I prefer always doing this first and then doing this second. So we will do f of g of x first. So f of g of x, you must get an answer equal to x. And you can't just say, oh, it's x, because I won't give you any credit for it if you don't show any work. So we are going to start with the input. We're going to start with the innermost parentheses. So we're going to start with g. So we're going to look at the g function. Maybe I should highlight this. So this can be f. Oops. Yeah, that's fine. And then this can be g. And the next thing I'm going to do is I'm going to make sure that I call this, so you guys know that that's actually G, and the green one is F. So we're going to start innermost with G, because we're starting in the inside of the parentheses and then working our way out. So we are going to write this. So because we're starting with G of x, so notice G of x is the same thing as this, which is the same thing as all of that. So we have f. We are just going to replace the entire right side of our yellow highlighted function with 1/3 x plus 5/3. And we're done. That's our output. So now we go to, or I'm sorry. I'm so sorry. Now we're going to replace the right side of that yellow highlighted function, because this is the left side, with 1/3. Okay, I'm confused here. Got confused. So we are going to f now. So we're going to f, and if you look at f, f is the green highlighted function. Wherever you see an x, you're going to replace it with all that stuff in parentheses we just wrote. So we are going to replace, so we have this 3, but then we're going to replace the x with all that stuff in parentheses. So 1/3 x plus 5/3. Close your parentheses, minus 5. Don't write too large, because we have to verify that g of f of x is also equal to x. So now we're going to distribute. 3 times 1/3 is just 1, and you have the 1x. And then 3 times 5/3 is 15/3. And if this bothers you, if you want to write that as 3/1, that might make it easier. So then you would have your 3's would cancel, your 1's would cancel. You're left with x plus 15/3 minus that last 5. So that's x plus 5 minus 5. Hey, look what happens. 5's cancel and you're left with x. So it does check. Because remember, we had to say f of g of x had to equal x. And now let's do g of f of x. So this time we're going to start with f of x, and f of x is right here. So it is 3x minus 5. So you have the letter g times 3x minus 5. Now you go to g, and you're going to replace wherever you see an x with that 3x minus 5. So start with your 1/3, and then replace that x, that's right here, with 3x minus 5. Close your parentheses, plus 5/3, and pray that this equals x. So distribute. 1/3 times 3x is just x, and 1/3 minus 5/3 is negative 5/3. And looky here, these cancel, and you're left with x. Should have probably done this. the check mark there. There we go. All right, and that's how we showed that the inverse functions, or that the functions were inverses of each other. Let's do a second one. So our highlighted function, so this is f, and this is g. Okay, so this is all right, and I'll put it down over here. So the first thing we want to do is we want to show f of g of x is equal to x. So f. So we want to know that that's going to end up equaling x. So start with g. And g of x is x squared minus 2. Now go to f and replace any x with x squared minus 2. So this x should be x squared minus 2. Then you have the plus 2. I should show that I'm replacing it in parentheses, so that makes it, I don't want to take any shortcuts. So we have x squared minus 2 plus 2. No c's cancel. So you have x squared under the square root. And remember, if you take the square root of x squared, you get x. So that is true. Now let's do g of f of x. This time start with f of x, which is square root of x plus 2. Okay, so go to g and replace wherever you see an x, which is right here, with an x, with a square root of x squared, x plus 2, sorry. But then notice you do have to square it. When you square a radical, you're just left with the contents inside. You don't have that radical anymore, because that's square root of x plus 2 times square root of x plus 2, which is just x plus 2. And then you have the minus 2. Those cancel, and you're left with x. So that you verified. And that's how you show that two functions are inverses of each other. It's a lot more work than showing two relations, or showing that, or how to write an inverse relation, sorry. Okay, our last little topic is called using the horizontal line test to determine if a function will have an inverse. So in semester 1, we talked about the vertical line test. We used that test to see if a function, or if something was a function. And so we had a graph and we drew vertical lines, and if it only touched the graph at exactly one point, it was a function. For the horizontal line test, I'll move that, it is used to test the function f to see if the inverse of f, which is known as g, or this is a notation you can use, or g, is a function. The inverse of f is a function if and only if no horizontal line intersects the graph of f more than once. So let's just do some practice ones without an equation, where I'm going to sketch a graph, and then we're going to use a horizontal line test. So I'm going to sketch a graph that looks like this. And then you want to, and you can put a dot anywhere on the graph, like you could put it here, you could put it there, whatever. Just figure out a point where you want to draw a horizontal line through, and I will draw a horizontal line through this one. Since the horizontal line only touched the graph at one point, then the inverse of this graph will also be a function. So this right here is just f of x. Now we're not going to draw the inverse on this particular one, but we know that the inverse will be a function. So the inverse is a function because f passes the horizontal line test. Let's do another one. Let's do one where it doesn't pass. So I'm going to draw my function f. So this can be what f of x looks like. Okay, so this is f of x, or just f, since I called it f of x. Oh, there we go. And now pick a point anywhere you want on the graph, and I will pick this one. Not that it matters. And then draw a horizontal line through it. Well, if you notice, it actually crosses right there as well. So this failed the horizontal line test. Therefore, the inverse is not a function because f of x does not pass the horizontal line test. I'm going to be lazy and call it HLT, the horizontal line test, and you can too. That's what we did when we did the vertical line test. Okay, now for examples 5 and 6, and that will finish up our notes for today. We are actually given an equation, and then we are going to determine whether the inverse of f is a function. Then we actually have to find the inverse. So let's go over here. And the first thing we want to do is graph f of x. So what we should do is I'm going to draw a graph over here, and we're going to pick some easy points to plot so we kind of just know what the graph looks like. So there's a little grid. Try and make it somewhat decent. And then we can make a table of values here. We don't need many points. So let's pick some easy numbers. So let's pick like -1, 0, and +1, and maybe that'll be enough points. So if we replace -1 in f, so we have 2 times -1 to the third power plus 1. Well, -1 to the third power is just going to be -1, and -1 times 2 is -2 plus 1. When you replace 0, that's easy. Anything times 0 is 0, so 0 plus 1. And when you replace 1 right here for x, you get 1 to the third, which is 1, times 2 is 2, plus 1, so it's 3. So let's plot those ordered pairs. So we have -1, -1. I should make some marks here. Okay, so we have -1, -1, which is down here, 0, 1, which is up here, 1, 3, which is right there. These are not going to be in a straight line, though. These are going to be curved because it is a polynomial. Whoa. I don't know what I did. But there. So this is what the graph is going to look like. Right? So that's the graph. Now you can draw a horizontal line anywhere on that graph. You can even draw it right here. Notice it touches the dot that's on the graph at exactly 1 point. So it passes the horizontal line test. Therefore, the inverse will be a function. Now we have to go and find the inverse. So we have to do what we did on the previous page. switch x and y, and then solve for y. So let's do that. So step number 1, switch x and y. And so this is y. So it becomes x equals 2y to the third plus 1. And then step 2, solve for y. So we want to subtract 1. Let me just write my y stuff on the left side. So subtract 1. 2y to the third equals x minus 1. Divide both sides by 2. So we have y to the third equals x minus 1 over 2. We're not done because we want to know what y is, not y to the third. Because y is to the third power, we are going to take the cube root of both sides. So our final answer is y equals, there is no plus or minus when there's cube roots, the cube root of x minus 1 over 2. And should you write it as y? Here, I would not, you don't want to write it as y. And the reason why is where you're finding the inverse. So what we want to do is we want to change that. And we want to write it as either g, or you can write f inverse. But you can always put g. That's okay. All right, and our last example. So we are going to sketch a graph of this particular problem. And I will go ahead and make some marks. We shouldn't have started there. We're just going to make a rough sketch of the graph. We don't have to be perfect. And so make a table of x and y values. And again, I would do -1, 0, +1. We don't want to go too big. So replace -1 in 5x squared. So -1 to the second power is 1 times 5 is 5. 0, 5 times 0 squared is just 0. And this will be a +5. And that could be enough points where it should be. So -1, 5. And of course, my graph's not big enough. That's always going to be the problem. And here it is. So there we go. So go left 1, up 5. These aren't very even. That's okay. 0, 0, right 1, up 5. At least you know what the graph looks like, and that's more what I'm interested in. It's U-shaped. There we go. And then we're going to draw a horizontal line somewhere. So there. Notice it's going to touch the graph at 2 spots. So this fails the horizontal line test. So does not pass the horizontal line test. So the inverse is not a function. But you can still write an equation for the inverse. You're just determining whether the inverse is a function. Every equation has an inverse equation. It just may or may not be a function. So let's go ahead and switch x and y. So this is y. So x equals 5y squared. And then step 2, solve for y. So I'm going to put the 5y squared on the left side. Divide by 5. Y squared equals x over 5. Then take the square root of both sides. Y equals plus or minus, and that's why it doesn't have an inverse, because of that plus or minus. And then just call this G, or the inverse. And those are your notes for today. Have a great day, Algebra 2 students.